All right, in this explainer, we're going to level up your web security game. We're moving past the basics to explore the advanced HTTP headers that'll help you turn your application into a real digital fortress.
So you've probably already built the basic walls for your web app's defense, right? Things like HTTP and a solid content security policy. And hey, that's a great start. But a fortress isn't just about high walls. It's about securing every single window, gate, and secret passage. Today, that's exactly what we're going to do, build those advanced defenses. Okay, our first line of defense is the watchtower. From up here, we get to decide what special powers our application, and yeah, any third-party content it uses, is even allowed to access.
Now, this control center is called the Permissions Policy Header. You can think of it as the guard up in that watchtower. This guard has a list of all the sensitive equipment, like the camera, the microphone, geolocation tools, and they decide who gets to use them and when. It's all about shrinking your attack surface by just plain disabling features you don't actually need.
And just look at how simple yet powerful this is. This one line says it all. Geolocation equals self. That means only our own site can ask for the user's location. And camera equals empty, that means nobody gets to use the camera. Not us, not anyone else. It's a clear, explicit no.
So how does it work? Well, it's really straightforward. The browser asks for your page. Your server sends back the page content, and along with it, these permissions policy rules. Then, the browser takes over and enforces those rules, making sure no part of the page steps out of line.
And here's the crucial part. If a feature isn't on your list, it just falls back to whatever the browser normally does. So here, you see we didn't mention the microphone at all. That means the browser will handle it like it always does, probably popping up that little prompt asking the user for permission. You only have to define what you want to explicitly lock down.
Excellent. So with our watchtower secure, let's head down to the gates. A fortress is only as strong as its borders, right? And on the web, those borders are getting crossed all the time by resources from other domains or origins. So we need a dedicated team to manage all that traffic.
So meet our border security team, Corp, Coop, and CoAP. This cross-origin trinity works together to build a super secure, isolated environment for your application, protecting it from a whole class of really nasty attacks.
First up is Corp, our customs agent. Its job is to look at your assets, your images, your scripts, and decide if other websites are allowed to pull them in. This is huge for preventing other sites from just embedding your stuff and maybe even leaking sensitive data.
By setting Corp to same origin, you're basically telling every browser on the internet, hey, these resources are for my eyes only. Only pages from your exact domain can load them. It's a super simple and effective way to lock down your assets.
Next, we've got Coop, the gate guard. So imagine a malicious site opens your app in a new tab. Normally, that bad site keeps a connection open and could potentially start messing with your page. Coop is the guard that just slams the gate shut, cutting that connection and keeping your app totally isolated.
And just like with Corp, a simple same origin directive is all you need. It tells the browser, look, if the site that opened this window isn't from my domain, cut the connection. This is a direct defense against attacks like TabNab.
And finally, there's COEP, our really strict loading dock supervisor. This policy kind of flips the script. Instead of controlling who can load our resources, it controls what resources we are allowed to load. It enforces a very simple rule. I will not accept any packages from other domains unless they are explicitly marked for delivery to me. The Require Corp directive is what makes this happen. It demands that any cross-origin resource has that Corp header we just talked about. Now, what's the payoff for being this strict? You get access to really powerful browser features, like shared array buffer, that are only available in this kind of secure, isolated environment. So let's just do a quick recap of their jobs. Corp is outward-facing. It protects your resources from being taken. Coop secures your app when it's opened by others. And CoAP is inward-facing. It protects your app by vetting the resources it brings in. Altogether, they create this truly isolated and secure bubble for your application to run in. All right, our watchtower and gates are secure. The final piece of our fortress is the internal vault, where we store our most sensitive documents. On the web, that's the browser's cache, and if we're not careful, we can accidentally leave top-secret info just lying around.
The cache control header is our protocol for handling this. Now, it's often used for performance, but it has a critical security job, telling browsers, CDNs, and any other proxy in the middle not to store sensitive information. I mean, you wouldn't leave a user's financial data on a public library computer, right? Well, this header prevents the digital version of that.
This right here, this is the combo you want from Maximum Security. It's a real belt and suspenders approach. No store is the most direct command. Don't save this, anywhere, ever. The others add extra layers, telling the browser to always double-check with the server and that the content expires instantly.
Let's just break that down real quick. No store is the strictest rule. It forbids saving the response anywhere, period. No cache is a little different. It allows storage but forces a recheck with the server before it can be used, and must revalidate make sure stale content is never served without getting an OK. When you're dealing with sensitive data, using all three gives you the best protection.
And there you have it. By putting these advanced headers in place, you've fundamentally upgraded your application's security, transforming it from just a simple house into a seriously well-defended fortress.
So, to recap, each header plays its own vital role. The permissions policy is your watchtower, limiting potential threats. The cross-origin trinity are your gatekeepers, managing all the traffic coming and going. And cache control is your secure vault, making sure sensitive data is never, ever left exposed.
And you know, these headers aren't just passive settings. They are active shields. They're your application's first line of defense, working silently and tirelessly before a firewall or even your own application code gets a chance to run. Making them a default part of your development process isn't just a good idea, it's just what modern, secure engineering looks like.
So there's the path forward. You now have the blueprints for the watchtower, the gates, and the vault. The only question left is, which one of these defenses are you going to build first?